In the brutal -20 degrees Celsius winter of northern China, more than 10,000 workers take on a task that seems almost impossible: building an entire massive city made entirely of ice, a glowing metropolis of castles, towering structures, and wide avenues created from over 7 million cubic feet of crystal-clear ice. Behind its dazzling beauty lies a massive construction operation, cutting tens of thousands of ice blocks from a frozen river, transporting and storing them for months, then assembling them with precision like giant bricks under extreme weather conditions. So how can humans build an ice city larger than Vatican City, only for it to exist for less time than it took to construct? Let's find out with Mandarin Tech. This massive ice city is built in Harbin, the capital of Heilongjiang province in northern China, where winters are long and temperatures frequently drop below -20 degrees Celsius, creating ideal conditions for harvesting natural ice from the Songhua River. It is the centerpiece of the Harbin International Ice and Snow Festival, held annually from late December to February, when the entire city enters its ice and snow economy season. In terms of scale, the ice and snow world alone can cover over 1.2 million square meters, using hundreds of thousands of cubic meters of ice and snow, with more than 10,000 workers completing construction in just about 1 month. But what's even more remarkable than its size is the massive economic impact it generates. In a single winter season, Harbin can attract over 20 million visitors, generating around $5.8 billion in tourism revenue. More than just a tourist attraction, this project has become a key winter economic strategy for China, turning extreme cold into a highly profitable resource and transforming Harbin into a globally recognized capital of ice and snow. Building the largest ice park in the world is truly a race against time. As early as November, when the river surface has not yet completely frozen, construction teams already begin preparing the foundation for the entire ice city. By January, once the ice reaches its ideal thickness, the first massive blocks are harvested and stored for nearly 10 months, ensuring the park's base is ready the moment winter returns. Across the frozen river, motorized circular saws carve long parallel cuts stretching for kilometers, forming a gigantic grid of ice, the structural framework of a temporary city built from solid winter itself. Once the circular saws complete the grid of cutting lines, human labor takes over. Teams of workers use heavy steel bars to pry the ice loose along the pre-cut seams. These synchronized impacts allow the massive blocks to separate along clean, straight lines with remarkable precision. In just 3 weeks, nearly 10,000 workers must harvest up to 7 million cubic feet of ice, enough solid ice to fill roughly 80 Olympic-sized swimming pools. When sub-zero air temperatures freeze the surface of the Songhua River, the water beneath continues to flow slowly and steadily. This constant movement acts like a natural filtration system, carrying away air bubbles and impurities as the ice forms. The result is a material that is nearly 99% pure water, exceptionally strong and crystal clear, almost like natural glass carved directly from winter itself. If a single ice block stops moving for just a few minutes, it can quickly freeze back into the river surface, potentially paralyzing the entire production chain. To prevent this, workers cut narrow water channels across the frozen river, turning them into a kind of liquid conveyor system. Because ice naturally floats, workers can guide half-ton blocks toward the riverbank with surprisingly simple pushing force. At the end of these channels, mechanized ramps pull the blocks up onto solid ground. These hauling lines use rotating chains fitted with steel hooks that latch onto the floating blocks from below, keeping them securely aligned as they leave the river and move into the next stage of processing. Once the ice blocks have been brought out of the water, forklifts and transport trucks work together directly on the frozen river surface to load and move the newly harvested ice. These vehicles keep the flow of materials continuous, ensuring the massive volume of extracted ice is transferred quickly to storage and construction zones without interruption. The trucks move to a storage yard located at the edge of the park area, a few hundred meters from the riverbank. At the storage site, excavators stack the ice blocks into giant ice piles that can hold about 20,000 blocks, with a total weight of more than 9,000 tons. These blocks must be stored for nearly 1 year before being used to build the ice city. To prevent them from shrinking or melting, the construction team relies on a physical principle known as the cold trapping effect. Cold air is heavier than warm air, so it naturally settles downward and becomes trapped between the ice blocks. This creates a natural cooling system inside the piles, maintaining temperatures below freezing even during the summer. However, keeping the foundation dry is also very important to avoid the bathtub effect. If even a small amount of water collects underneath, it can retain heat and cause the base of the ice pile to melt. Once an ice mountain is completed, workers cover it to ensure the ice does not melt. First, they place straw mats over the surface. Each straw fiber acts like a tiny hollow thermal flask, trapping air inside. Millions of these small air pockets form an insulating barrier that slows down heat transfer during the summer. On top of the straw layer, the construction team adds another protective layer made of white foam panels and giant white tarps. These surfaces act like large mirrors, reflecting solar radiation back into the atmosphere before it can reach the ice blocks. This protection system is so effective that throughout the entire year, the ice blocks lose less than 10% of their total volume. The ice mountains now enter a long period of dormancy. 10 months have passed since the ice was harvested, and it is now November once again. The ground has completely frozen over. And now it is time for them to begin the construction of the ice city. The construction team must follow an extremely strict schedule because they have only 30 days to build an ice city covering more than 250 acres, roughly the size of 190 football fields. First, engineers erect a massive steel framework for the central tower, which stands over 108 feet tall. This framework acts as the backbone of the structure, supporting millions of pounds of ice. Without this internal reinforcement, the tower could shift in strong winds or collapse under its own weight. However, in temperatures as low as -20 degrees Fahrenheit, ordinary steel can become brittle like glass and lose its load-bearing capacity. For this reason, the steel used here is a special low-temperature resistant type, delivered to the site in the standard length sections. Mechanical engineers then carefully weld each component together, assembling the structure into a complete frame according to the original design drawings. Welding this type of metal is also a high-risk task. The welding torch can reach temperatures of up to 2,000 degrees, which can cause the steel to crack instantly. However, the special alloy used here is designed to withstand this thermal shock, ensuring that every weld joint remains strong and secure. The steel framework of the structure is designed to be hollow inside, creating space for the installation of kilometers of electrical wiring that will allow the tower to light up after completion. First, large sections are assembled directly on the ground, then carefully lifted and secured into the main structure, requiring absolute precision. On the other side of the park, excavators begin shaping a large earthen hill to serve as the foundation for the Grand Slide, the park's main attraction. The goal is to create 2 long, winding sliding tracks for visitors to ride down on sleds. Before covering the surface with ice, workers install the technical infrastructure along the slope, while also using metal lifting baskets to inspect and weld steel joints at elevated positions. The most critical part of the entire ice city is its electrical system, with a total of more than 93 miles of cables running throughout the structures. Thousands of LED lights can generate enough heat to melt the ice, allowing moisture to seep into connection points and cause electrical arcing that could shut down power across the entire park. Therefore, all connections are sealed with 3 layers of waterproof protection to ensure the system operates reliably throughout the winter season. Once the steel framework is completed, the construction team begins bringing in the first large ice blocks to cover the structure. After more than 10 months of storage, workers begin removing the insulating covers to take the ice blocks out of the storage yard. Due to long-term pressure, many of the lower blocks become stuck together or slightly deformed, so they are used for the internal structures of the buildings. The more uniform blocks with cleaner surfaces are selected for the outer sections. After that, the storage area enters a large-scale loading and transport phase. Excavators directly lift the ice blocks from the large piles onto truck beds, while trucks continuously deliver the material to the construction site, forming a steady supply chain to support the next stage of construction before the new ice harvesting season begins. When the ice blocks arrive at the construction site, workers begin sorting them by quality for different construction purposes. When strong winds reach dangerous levels, crane installation work must be temporarily suspended to ensure safety. The construction crews are then redirected to build the super slide, which is about 1,600 feet long, equivalent to the length of 5 football fields, where work can continue safely at ground level. Construction teams also begin assembling the circular ice tower, inspired by traditional Chinese architecture, where the ice blocks support each other in a ring formation, meaning that if even one block shifts out of place, the entire structure can lose stability. When the strong winds subside, the construction site immediately accelerates operations, with a workforce of about 10,000 people working in coordination like an industrial production line. Electrical crews quickly deploy the high-voltage cable system before it becomes sealed under layers of ice, while workers place the first foundation layer of ice for the central tower, a base that must be perfectly precise, because even a small crack could cause the entire structure to collapse. Meanwhile, artificial snow machines produce large volumes of snow, which are transported by loaders and dump trucks to build structural models and create the walking surface layer across the entire park. The snowflake and star-shaped patterns on the ground are not only decorative, but also help distribute the load of the 108-foot-tall central tower, preventing settlement or tilting when ground temperatures change. The construction teams have only one chance to install the LED lighting system, because once the next layer of ice is placed, the entire system becomes sealed inside the ice and can no longer be repaired. Thanks to the ice's 99% purity, the light is still able to maintain its clear colors even through thick layers of ice. However, when an unusual warm spell raises temperatures to about 39 degrees Fahrenheit, the ice begins to soften, forcing the site to temporarily suspend construction of the main tower and the slide, as well as stop crane operations and snowmaking machines to protect the foundation. During this period, the construction teams shift their focus to completing ground-level structures such as the Warm Castle, covering about 54,000 square feet, and the Pony Family Relief at the Southern Gate, a symbolic structure representing the upcoming Year of the Horse. As winter enters its peak period, construction begins on the Grand Slide, the most popular attraction in the park. The slide consists of a steep main slope, a sharp curve in the middle, and a long deceleration section ending with a final ice barrier wall. The structure is more than 17 feet long and is designed with a Great Wall-inspired theme. It is also the fastest-built project in the park. In just 16 days, the teams completed 24 parallel sliding lanes. The sliding channels are cut into square grooves to keep sleds moving in the correct direction. Although each ride lasts only about 40 seconds, visitors often have to wait up to 7 hours for the experience. A scaffolding system is installed to create walkways and working positions as the heavy ice blocks are lifted to higher levels. Because ice is very brittle, it cannot be drilled directly to secure metal frames, so the scaffolding is erected around the structure without touching the ice tower. In addition, metal can absorb solar heat and cause the ice to melt if it comes into contact with the structure. Therefore, wooden pads are placed under each scaffolding base, helping stabilize the system while workers operate at height. Another project is built directly on the Songhua River, a 1:6 scale model of the Liaoning aircraft carrier placed on a floating barge. Because construction takes place on water, the ice blocks must be carefully balanced on both sides to prevent the barge from tilting. The structure is about 230 feet long and uses 353,000 cubic feet of ice. Workers use scraping tools and hand saws to shape the hull of the ship. Thanks to the moist river surface, the ice blocks bond together more quickly than they do inside the park. At night, an internal LED lighting system illuminates the model, making it stand out prominently on the river surface. The most important structure of the Ice City is the Central Tower, which stands 141 feet tall. As temperatures drop, the ice contracts and tightly grips the internal metal framework, creating a strong bond that allows the tower to withstand winds of up to 40 miles per hour. After construction is completed and the scaffolding is removed, This 14-story structure becomes the main landmark of the entire park, which covers about 13 million square feet. Even in very cold weather, sunlight can still slightly melt the surface of the ice, causing cracks or making the blocks turn cloudy. To fix this, workers use a mixture of crushed ice and water, slush, as a kind of ice mortar to fill gaps in damaged areas. The mixture freezes almost immediately and restores the structure. In the same way, construction teams also build many other large-scale ice structures throughout the park, ranging from palaces and towers to circular architectural forms and fortified walls, gradually bringing this massive project to completion. After 22 days of continuous construction, the site is completed and ready to open. This ice city exists for only about 60 days before melting back into the Songhua River, where the ice was originally harvested. The 26th Harbin Ice and Snow World is officially ready to welcome visitors. When it opens, Harbin Ice and Snow World operates daily from 10 a.m. until midnight for about 2 months, usually until the end of February. Each day, the park receives around 30,000 to 50,000 visitors, totaling roughly 3.56 million visitors per season. The standard entrance ticket costs about $50 per person. If you travel from the United States to visit this festival, the total trip cost is typically around $2,000 per person for round-trip airfare alone, not including accommodation and food. If it were you, would you choose to visit this place at least once to experience it? Let us know what you think. Thanks for watching, and see you again in the next videos.